This is part 2 of the inverter videos. In the last video I said 62 hertz. That was wrong. I should have said 60.2 hertz, which is pretty good, real good. That's as close to 60 as you can get. Well, almost. I checked the fuses, and sure enough, they had the wrong fuses. I don't know if you'll be able to see that, but that's 40 amps. According to the manual, if the manual is correct, this should have 20 amp fuses for the 24 volts. So when they did the conversion, they didn't swap out the fuses, plus the spare fuses were wrong also, assuming the manual's correct. That would kind of leave this unprotected. So I'm really glad I took this apart. I'm going to email them to make sure that's correct. I'll post what they sent me. They have a little write-up on how to test these FETs. And I also found a good web page for repair information on inverters. I'll post that also. But anyhow, this is the document. And we're basically just reading on diode check a couple points on a FET. That's kind of iffy because you can't always test them that way. That's where a scope is nice, or you have to pull them out of a circuit. I tried to do the test with my $3 voltmeter, but it doesn't work very well on diode check. So I'll have to bring another one, or that should be better. That should work, or I should order, and probably I should just order a newer voltmeter. I was hoping this board, let's see. Also, when you before you open it up, disconnect. Of course, you disconnect the power, but turn it on after it's disconnected from the battery, because these caps are still charged up. You'll still hear this whine, and that should drain it down with it being on for a little while. And then don't forget to shut it off. Now why don't this move? Oh, I got it. I guess I'll have to move. Well, you can see it. This board here, judging from that photo, was the very popular EG-S002 board, and there's all kind of information on it, and it's super popular. Unfortunately, it's no longer this board. It sure looked like it, because if you're looking at other document about the FETs, you could kind of see this connector right about here. Yeah, let me try my other finger. Right about here. But it looks like they came up with their own design board, which is a disappointment, because you can buy these boards for like $8. It would have been so nice to be able to swap that out. On the positive side, I think it uses the same chipset, so we can get that chipset, or that chip, and that gives a lot of information. I think it's like an 8010. And also, if they didn't change anything, we have pinouts. We can get some information from this document to help us understand it. And later I'll scope this out and see if it's the same thing, same number of pins, unless they change something on their motherboard. Also, when they did the conversion to 24 volts, I can see maybe a resistor was removed and one was soldered in. They may, on this board here, they may have changed a resistor also. You would think one of these transformers would have had to been changed, or a couple of them, or all of them, but I'd have to take the board off, take it totally apart and look at the solder joints. That's how I kind of tell. Just visually, everything looks excellent. It's very nice soldering, and it doesn't look like bad workmanship from the factory. There, on the larger FETs, some of the solder joints might not be perfect, or are not perfect, but okay. So we found a couple of resistors that were changed and maybe one removed for the 24 volts. We really don't know for sure what else was changed, or we don't know. It's kind of hard to read the value on it because of the flux, but I might look into that more. I've collected a few component numbers to get some data sheets, and I kind of ran out of time, so I think that's about it. It's almost really, there's a lot of information on building inverters. It might be best to just come up with an open source inverter that it probably wouldn't take much more effort than making a gasifier, and keep improving. That way you know exactly what parts you need or how to swap stuff if you built it and understood it. Also, I think I mentioned I found a web page has quite a lot. It has some nice information on repairing inverters. I'll post that. Well, sorry for the short video. Take care.